Allô, Aslema? Rania, Aslema.
Aslema, ça va?
Rania, si ça va, نسمع فيك si ça va. يعيشك. Donc, prête à نبداو في اللايف.
نجم نبداو اما je vais partager mon écran كان battery en fait.
رانيا عسلامة.
عسلامة.
Oui. Donc, ce qu'on va faire, Rania, donc je vais présenter l'OL ou بعد كنجمو نبداو التالت معناتها juste نعطي une petite présentation عليك وبعد معناتها تنجم تبدا d'accord.
D'accord, ok.
بالنسبة لللايف sur YouTube معناتها رانا تو في اللايف sur YouTube donc عطيني juste quelques secondes pour faire le live sur le Facebook ونرجع لك.
D'accord, ok.
محمد يحيى عسلامة ومرحبا بك.
Ça va?
سي سافا محمد يحيى من السودان دونك يتبع فينا معناتها عنده برشا يتبع في الأنشطة نتاعنا.
والله أنا سعيد جدا إنه أحضر معكم و very more glad to attend your some lectures. I'm very enjoyable with your meeting and very glad to follow you at any lecture in future إن شاء الله.
شكرا يعيشك.
سعيدين وشاكرين النشاط الدؤوب الذي تقوم به الأخت والزميلة ميساء اليزيدي ونحن شاكرين ومقدرين لمجهودها الجبار وإن شاء الله نحن نظل متابعين ولقدام حيكون لدينا إن شاء الله تعاون معكم خصوصا بحمد الله انتدبت إلى مجمع الفقه الإسلامي دائرة العلوم الطبيعية والتطبيقية ولديهم شغل كثير في البرنامج بتاع الأويرنس في مجال الفضاء والفلك ورصد الظواهر الفلكية. إن شاء الله سوف يكون في المستقبل هناك تعاون بإذن الله تعالى بيننا وبينكم إن شاء الله. إن شاء الله.
إن شاء الله. شكرا يعيشك.
Thank you so much.
دونك راني جست غمارك صغيرة دونك كيفاش نعمل معناتها لايف باش تتسكر الكاميرا معناتها من زوم مي جو سوري توجور لا معناتها راني ديما موجودة.
D'accord, ok.
Donc, mes co-hosts, yes. Rania, la présentation, ça va être بالعربي ou بالفرنسي?
La présentation, elle est en anglais. Donc la question, est-ce que نجم نحكيها بالانجلي ولا لازم نبدل نحكي بالعربي؟
نو معناتها بالنسبه لي نحن معناتها ني با معناتها سبيسيفيك في لونغ محدده معناتها فوزيت ليبر معناتها جوست اللي يساعدك انت.
D'accord, juste باش معناها باش نعرف معناها est-ce que je peux utiliser l'anglais juste purement anglais pour la présentation ولا لازمني ندخل عربي وفرنسي وكل يعني pour être plus
بون كيما تحب معناتها تحط l'anglais comme une langue معناتها officielle كيما تحب اللي يساعدك انت معناتها نصور معناتها كنا نفهموا l'anglais هنا anglais ولا عربي donc je pense que l'anglais معناتها ça va être homogène.
Très bien.
Donc on est en live sur YouTube et sur Facebook, les pages Facebook Montana. Donc hi everyone, I would like to welcome everyone today for another session of us. Today we have a special guest who is Rania Toukebri in aerospace engineering. Rania Toukebri, she is a space engineering working in the space architecture like space medicine, JUICE, biomass, Plato, and HERA. She is also a regional coordinator for Africa and Space Generation Advisory, the Council in support of the United Nations Space Application Program. She is also the UNOOSS delegate, scientific and technical subcommittee, the Moon Village Associate Fellow Architectural Concepts of the Moon, and also she is a member of the organizing committee of the African Union Commission Space Activity, Space Policy Consulate in Africa, an African country, and also Rania, she is really one of the amazing aerospace engineering in Tunisia. Rania today, she's gonna give us talk about planetary defense. Planetary defense is really one of the very interesting topic around the world because it's very important to talk about it because it's one of the most attractive subject in space exploration and also between international space agency around the world. Rania Toukebri, she is really one of the famous, I would like to say, space engineering in Tunisia, working in Germany right now, and she's gonna give us an amazing lectures about space defense. Rania, you can start.
Thank you, Maisa, for the introduction. Okay, I will not introduce myself more. So I'm Rania, I'm a space engineer, I'm Tunisian. I make the architecture of spacecraft systems and subsystems as well. Also, I work on the verification and integration of subsystems for telecommunication subsystems as well, and also the communication with the ground station, the storage units, and all this nice stuff, the onboard computer, basically. And as Maisa mentioned, so I'm regional coordinator for Africa for Space Generation Advisory Council. That is an organization in support of the United Nations for Space Program. And that is making a huge work across Africa since like a lot of years, since I believe 1997. And it's actually having more than 115,000 members and from 150 countries around the world. And thank you so much for the invitation. Today, I'm going to talk about the major topic. I believe it's one of the most important ones, which is planetary defense. So this is something we should, all of us, be aware of, and we should try to make an international collaboration, not only through the technical and scientific collaboration, but also by outreach and by raising awareness about this, just to make everyone knowing that investing in this topic is also like a major thing because it saves all our lives. So that's why actually we chose to have this talk today. And I'm actually part of one of the first missions ever that are gonna to exercise the impact to see if we are really able to defend ourselves from an asteroid or not, if we have enough technologies to do it or not. This is a project from ESA and NASA as well. So I'm gonna give more details a bit later. I can maybe start sharing my screen, Maisa?
Yes, you can.
All right. So this is planetary defense. I think you know this big asteroid that just was the cause of the like the death of dinosaurs.
Rania,
So
we lost.
yes, can you hear me?
Rania, we cannot hear you very well.
Okay.
Rania,
yeah.
we cannot hear you very well. I think they are like internet issue.
I will stop my video just to make it a bit better. Can you hear me now better?
Yes, I do.
All right. So I stopped the video just to make the connection better. So let me know if there is any issue. Thank you. So here I wanted to put the finger on what is basically meteorite, what is asteroid. So this is actually an image of what we call the hard rain that is coming from the small particles called meteorite and meteor. So this is meteor is basically in the atmosphere and meteorite is on the ground. So this is just a small introduction of the dimensions of meteorites, of asteroids. If it's up than 1 meter, it's called asteroid. Less than 1 meter is called meteoroid. And the average size basically is like sand grain, as you can see in the picture. And the bright ones are rice grain. And the energy is traveling for over 20 kilometers per second. This is just for the people that are not really familiar with this. So here, I think some people just heard about the impact that has been in January 2018 in Michigan. It has actually caused some issues and some disruption of some buildings, a rain of meteorites that has been coming from the orbit between Mars and Jupiter, and it has been captured by the weather radar just to have a high resolution, and also from other spacecraft resources. So as you can see in the picture up, so you can see the dimension of these meteorites. This is a very small thing, but the energy can really cause a huge impact, huge disaster after it. So this is a picture I chose to show you. This is actually what the US government sensors are reporting in Mars 2019. This is actually showing from the degree of energy, the impact energy. And the big one is, as you can see, that was in Russia in 2013. That was, and also 440 joule. Also, the other one was in Bering Sea in 2018. And actually, the other ones has just made not very major impacts. This is a NASA resource. It's just 2019, but you can imagine there is actually more. Why I wanted to show you this, just to show you that it's very important that we are able to track and to find and to see and to show what are the impacts, where are the major impacts, if there is any specific areas that can be impacted more than others. This is also other pictures I wanted to show you about the impact that has been in 2013 and the dimension of the meteorite that happened, the asteroid, sorry, that was there. So it's not really that huge, but the impact can be really big. So it caused 1,613 injured citizens and around $20 million damages. So the effects here, you can find one of the effects that was from 1908 till 2008. So the damages was still there, and it can even last more. So that it's really, you have no idea how this really can last a long time in Earth. So just in order to be reestablished again. So this is the object, as I have written here, that an object estimated to be 40 meters in size. It entered the Earth atmosphere or the Tunguska River in remote Siberia that caused all this damage since more than 100 years. Another effect here that is in Arizona in USA, the big crater, the famous crater that is similar in the moon and Mars, and it's dated like over 15,000 years ago, and the dimension of 160 feet, basically 50 meter of diameter of the impactor. Here, this is the famous asteroids that caused the death of all the dinosaurs. So it has happened in 3 steps. For first, the impact, then causing the tsunami, and then the debris transport. I think you are all familiar with this topic. So this is basically what happened to like 5 minutes after it. It's the molten rocks high in the air that turn into small glasses as they cool and fall and killing all the remaining feline dinosaurs, a part of the tsunami, of course. So that has been like over 65 million years ago, and it has been like a huge explosion crater around 180 kilometers across. Here, there has been the danger zones in Earth about the chances of colliding with Earth. And these are basically what's up to now. So we can find more, of course, what are basically the danger zones. But no one can really be, can avoid it if it happens. And it can really impact the whole Earth if it happens in one single point. The international interest has been really raised since years for the scientific interests and for also the resources income that it can bring. So for the small ones and big ones as well, you can see, I think, Mesa, you are actually more familiar on this topic. So the compositions of the meteorites can be a huge resource for us, for our research, and for our also as an energy resource as well. Since, like, I believe 60s, there has been a lot of reports from the US government, from the international institutions, as you can see on the UN Copious Committee of Peaceful Uses of Outer Space, that have made several policies and several space programs on this topic, just to show you how important it is. So here I showed you the different institutions that interact with each other in case of issue, in case of a threat, basically, that has been coming from the Copious meeting. To the member states, the International Asteroid Warning Network, the Impact Disaster Planning Advisory Group, the Space Planning Group, and also, of course, they are interacting each other to check in case of the deflection, space missions, plans, the response plans, the analysis, the observations. Actually, they interact with each other in case of if there is any threat coming out in the coming years or days. But just to say, so unfortunately, we're not really able to track all kind of meteorites and asteroids so far. We have a huge capacity of tracking the big ones, but for the small ones, it's still a challenge for everyone to make it happen. So here, since we will talk more about the missions that will be generated or will be made for this purpose, I just wanted to show you how things happen for planetary defense, how things are, and how we track and make the decisions at the end. There is basically 5 major steps. There is first coming from the research, detection, and track from the ground bases, from the different telescopes and institutions and space-based observations. There is a characterization that is basically also from the observatories and also from our labs in US, in Russia, in Brazil, I believe also there is some in Asia. There is a plan and coordination that is also very important. The mitigation, the exercises that we should do to deflect the asteroid and the access at the end. So here also it's important to know what is a close approach, or what we call the near Earth orbit objects. So this is actually any kind of object that is close to our orbit. We call it, even like there is a close approach to our orbit, we call it a near Earth orbit objects. And we make all our measurement based on this entity. Once there is one close in by, we try to track it. Even the sizes should be very small. We try to, at least. Here, as I said, this is basically the prevention techniques, or the steps techniques that we should just have in mind. Once we talk about planetary defense, we should find out the asteroid. And as I said, again, it's unfortunately, we cannot really make find out the majority of the smaller asteroids, but we have made a big step of discovering the big ones. There is a second step that is a tracking. Here, once we find out that there is any threat or any possible near-Earth orbit coming, so we try to find out and to follow it up during days, months, years, and even more. The characterization, and here we are making really a good research, a good development on research, and this is coming out from telescopes data, the observations, just discovering the compositions and the physical properties and masses and all this nice stuff. The fourth step is the deflection, and this is basically my topic. So this is the exercise that we will make in order to change the orbit, or to slam, or to destroy, or whatever, just to avoid having any kind of threat or any kind of impact on Earth. So, and this is actually, you should just put in mind that this is actually dependent on the warning times, on the size of the object. So the different techniques or the different possibilities of deflection depend basically on these two factors, which is, as I said, the warning time and the size of the object. The fifth step is a coordination and education, and this is also very important because this is actually puts the governments aware of this, so that they take the possible prevention techniques that they will try to coordinate with the observatory around the world. They will try to make any kind of labs for treating data. They will try to participate to the international work on the tracking, finding, characterizing, or just deflecting. Here again, this is the different institutions. So I wanted actually to show you this, to show you that this is basically a US coordination, but this is actually international one. We have from the mitigation actions from NASA, different institutions, laboratories as well, to also even Amazon Web Services and Microsoft Azure have really a role on this side. So just go into the big data management simulations, the analysis of material characteristics, the physical chemical properties, and all the analysis that comes out from this. The find and track in the first step, this is actually what we use to find and track. This is a few telescopes, either from ground or from space, different missions that have been here so far, and there is actually several other ones that are coming out by. Here, as I said, we made a big step on the tracking and finding near-Earth orbit objects. So here, it's actually from 1973 to 2015. It's not really up to date, but this is what they have found at the end. So you can see the number of near-Earth orbits is growing. It's not because there are more, it's because we are able now to track more. And just when we make a comparison between the statistics of 2010 and 2018, you can find that how much we can find objects that are between 140, 300 meters from 5.9% to 15.4%, just to see how much work we have done in just 8 years. Also, the other ones that are more than 1 kilometer are the most dangerous ones. This is actually what we try to find out during the years. Characterization, it's, as I said, a work of telescopes. So you can see here the Spitzer Space Telescope that has been retired, actually will be retired, like I think very soon. The Arecibo Observatory that is unfortunately ending his missions, and we will maybe make another one. And there is the NASA infrared telescope facilities that is tracking like stars, basically for stars and for Earth exploration, for other planetary exploration, and also used for asteroid tracking as well. And this is actually some pictures that came out from Arecibo Observatory and Goldstone radar, which are actually the major ones used for tracking asteroids in the world. Actually, it has been in 2014, just to show you how they try to track, to characterize, and to see the size of the objects, basically. The step of deflection, this is actually the most important step for me. So this is actually different techniques you can see here. It's actually, there are more for sure, but this is the main ones that they just put in mind in case of a possible approach. So there is a slow gravity tractor, basically pulling out the asteroid. There is a mid-range kinetic impactor just to slam the asteroid, the small or big, the size it is, and to try to change the orbit. And there is the laser ablation and the nuclear option, which is actually the worst case scenario in case of our incapacity of changing orbit, our incapacity to manage the asteroid, sorry. Okay, just to come by the second method, this is actually the method we will use for our exercise. So just slamming the meteorite. Here, there is a mission of NASA and ESA. So here it's started by NASA. Basically, this is called the ADA mission. The ADA mission, this is actually using the DART kinetic impactor, using the second option I just mentioned. And there is a second satellite, or a second telescope, if I may say, that will actually track all what will happen, will take different measurements, will follow up how things will be. The purposes or the relevance of this project has three major objectives that are scientific, for planetary defense, and for exploration. For scientific, it's basically the estimation of internal structure and compositions of asteroids, which is very important for us as a resource. Also, the measurement of crater formation and redistribution of material, which is also very important for us to see if we are able to use specific technology for it. And also, the planetary defense purpose is to understand this method, the kinetic impact effects, for future deflection technologies. The exploration is basically to plan, to perform the characterization, the resource investigation, and more, and the coordinations as well. So this is basically the two the asteroid that we will try to go to. So this is a Didymos and Didymon. I think you all heard about this. The Didymos is actually the size of a mountain. It's 1,780 meter wide. And the Didymon is the size of like the Great Pyramid, if you know, it's like 160 meter wide. So what will happen is that the dart path, if just you follow the picture, you see that it will come like in a speed of 6 kilometers per second. It will slam it. It will change the direction, change the orbit. You can see the difference between the original orbit and the post-impact orbit that will change a little bit. And there will be at the end the eyewitness, which is actually the mission of ESA, the European Space Agency, that is using the asteroid impact mission AIM, or using HERA, which is the spacecraft that I will work in, that will try to witness, to track how things have been done so far, if we are able to do anything, if there has been any issue, and so on. So here again, another picture showing up the AIM mission that has, it's actually AIM that is close to the asteroid, and 2 small CubeSats that are also close by and that will be in there at the end. Here again, there is the mission that the 2 missions combined together. The DART that will come by now, actually it will be 2022, I believe. And HERA, it will come after a couple of years to check, to go around, to turn around this asteroid and to check if the crater, how it has been, to characterize it basically with infrared pictures, and to measure the mass as well and the different compositions of the asteroid. So actually, we are more interested into the small one, the Didymon, to see how if we are able first to change the orbit, and second to see if we are able really to if there has been any issue around after this kind of like exercises. So again, so this is the collision tool, spacecraft or satellite, or you can see what it is. So this is actually the tool that we will use to slam the asteroid, used by NASA. You can even make your research on this. It's actually driven planetary defense driven test of technologies to prevent an impact of Earth by a hazardous asteroid. So it's actually the first demonstration ever to see this technique, the kinetic impactor technique, and also to check to see if we are really able to avoid any collision. The second one, HERA, this is actually my satellite. HERA, it will map the impact crater left by DART. It will measure the mass by the hyperspectral images. This will just determine basically if we are able, what is inside, if we are able really, if we have enough technologies to change it or not. And this is just few pictures of how we estimate things will be and how HERA will make his job. And HERA actually, as I said, has basically 2 small CubeSats. The CubeSats will be very close to the asteroid. There will even be land on it, and there will be an exchange of informations between these two CubeSats and the main satellite HERA that will also bring the communication to the ground station on Earth. So the 2 tools used is actually the Apex CubeSat. It will perform a meteorspectral mineral survey. And the other one, we call Juventus, it is Italian, obviously. It's performing the first radar probe of the asteroid. So this is the technology, the instruments used for the persons that are more familiar with payloads. And the question is, what will be my role in here? So my role will be basically to design and to check the onboard computer, and also to check if these instruments are sending correctly the data, if the data has been stored perfectly, if there is any worst case scenarios, if the speed of sending data is proper or not. We try to check all possible scenarios that can happen in space. We try to check if the connection that will be between the satellite and the ground station is fine, and if the downlink properties are correct. All these scenarios and all this verification plan, actually, I plan it with my team. And of course, we participate to the design itself of the mass memory, where we store the data and where this data will be just downloaded to the ground station. These are basically some instruments. You can just check by the navigation camera flight, the PALT microleader, the thermal imager, the IP ICU, also the other instruments used for the Apex, the CubeSat. So actually, this is basically everything. Unfortunately, I'm not able to show you exactly what the mass memory itself or the onboard computer itself. Until we finish it, we cannot really show it, but I'm really open to your questions if you have any. Thank you.
Thank you so much, Rania, for the very amazing presentation and talk. So I would like right now to welcome the question, and the first question from our social media in the YouTube channel from Taysir. She said, "How many near-Earth asteroids have been discovered so far?"
So, okay, so the number exactly, I have no idea about it. So you have to know that the number is growing every day. What we have, it actually, I believe it has been 2015 around 200,000 near Earth orbit, I believe so far, 2015. But I don't know. Like actually, there is several telescopes like that are working around the globe, and actually tracking this and communicating this and finding it every day is actually growing. And I believe you know that there has been several ones passing by Earth in the last months. We heard this in the news as well. But actually, the exact number, I unfortunately don't have it right now. And just for us, this is actually the work of the Planetary Defense Coordination Office from NASA that has actually the mission to track and to check the exact number, the exact compositions, and the exact naming as well of these near-Earth orbit objects. My mission or my role is basically to find out any technique, any technologies used to deflect these properties. So this is a work, international, communication and international collaboration work, and each one of us has a specific task on it.
The second question is, what is the difference between asteroid and comet?
All right. So actually, the asteroids is, as I said, there is a big difference between, first of all, the asteroid and the meteorites. So again, it's coming out in the dimensions. So there is the small ones and the big ones, meteorites and asteroids. And there is the comets is actually a small solar system body that is passing close to the sun. It warms and it begins to release gases, and so it's also called a coma. So actually, what we have here, so these actually objects has been formed like a lot of number of years ago, 4.5 like billions of years or even more, and these are all possible to cause damages. And the difference is also among the energies that they have when they pass by. So basically the differences remains on the sizes and on the energy that they have, and where they belong, if they are close to the Earth or to the Sun, or in which orbit they are exactly.
The next question from Nizar, he said, how we can characterize the near-Earth object?
The characterization, it's made out of a list of properties. So what we do, we try to first to find out where if there is any possible or potential near Earth orbit. We try to check the masses, the properties, the size, the different composition, chemical compositions. Unfortunately, we don't have enough technology to check it exactly how it is. But once we find all these properties and we track it, all this through a matrix, we can find out and characterize these. And this is actually coming from work from the labs basically, and the scientific work that is after it. So actually Maisa, I think this is also your favorite topic, right?
Yeah, it does. And then the next question is from Asma. She said, how do the near-Earth object access asteroid impact risk?
Again, sorry?
How do the near-Earth orbit assess asteroid impact risk?
I don't know. Actually, it's the opposite. So the asteroid impact, if you mean the impactor, I don't know if I understood correct the question. The asteroid impactor, it's the tool we use to go to the asteroid. It's not the opposite. I don't get the question. Maybe it's the opposite. It's actually
Yeah, I think they are asking about that the risk made up by the near Earth orbit.
All right, the risk. Okay, as I said, the risk is we have no idea of how it will be. So you can see. So if it's just a small size asteroid of the dimension of the Eiffel Tower that has been like for 65 million years ago, that caused the disappearance of all the dinosaurs. It can also happen to us. So you have no idea how what can be really the impact of it. So this is limited. We don't know. We have no idea. It can cause either just small impact of several injured persons, that the one that happened in Russia. It can cause like basically nothing. We have meteorites that falls every day. In the Sahara, even in Tunisia, we have small meteorites found. But also, we don't know. This is dependent on the sizes of the asteroid and the meteorites as well. But the opposite is actually the impact that we do, the impact of the impactor to the asteroid. This is actually what we want to do, what this exercise is gonna make. If we are really able to have a great impact on the asteroid, if we are really able to change the orbit or to destroy it or else, this is actually the main question. We try to attack it before really being attacked by it.
Yes, that's absolutely right. I have another question from Mohammed Yahya. He was with us here in the Zoom platform. He said, على أي ارتفاع يعمل الكيوبسات الذي يستخدم لمتابعة الكويكبات؟ والسؤال الثاني، ما هي نوعية التقنية التي استخدمت لمتابعة هذه الكويكبات؟
اوكي. الارتفاع احنا الهدف متاعنا الاستعمال ما نعرفش نحكي تونسي ان شاء الله يفهم. نجم نستعمل تونسي؟ باهي. الارتفاع الهدف هو انه نحاولوا انه الكويكبات يعملوا landing, they land on the asteroid, so we try to make it the contact between the CubeSat to the asteroid so that they can track exactly the masses of it. And the technique used, it's actually the normal communication used between CubeSats. I think I have mentioned it in my presentations. I don't know if I mentioned this already. I was in the slide, but I didn't say it. It's actually the communication that will be between the spacecraft itself, the satellite, and the CubeSats. So this is communication normally used between satellites, inter-satellites protocols, and between inter-satellites communications. The normal Ka-band and X-band communication that happens between, that we use basically for normal satellites, from the satellite to the ground station. This will be basically the same for the communication between both of them.
Thank you, Rania. And then we have a question from Kelly. She said, my son, she want to ask why, he's 5 years old. He said, why asteroid impact Earth?
Okay, the stuff is that this kind of accidents, if I may call accidents, it actually happens, it's natural thing. So the asteroids were in the solar system and all over the globe as well, before, even with the creation of the solar system and of the Earth and of the planet. So this is a natural body that exists there. So, and the accidents happen every day. So we don't know, and we cannot really find out and explain how this happens. So maybe it's not even my field to understand the dynamism of these bodies, but this is actually happens in a normal state. We cannot really avoid it. This is like, I don't know, like floods, like any kind of natural disaster that we cannot really manage. What we try to do is just we try at least to defend ourselves in case of any potential threat or any potential accidents. So there is no why. It's actually, it happens like this, and it's okay, accident.
Okay, so I don't know if Sidqi Amr, do you have question? Okay, so then we move on to the other question from Nizar. He said, how to calculate an asteroid's orbit?
All right, so calculating this is again not my field. So my field is basically to to build the technology that will not really calculate the orbit, but that will really track things, the usage of cameras, radars, the possible communication between the satellites and all this. But calculation of orbit, actually, this is the work, again, it's the Earth of the Planetary Defense Coordination Office, and they do all they define the mission, they calculate the orbit, and they try just to give us the mission to build the technology. So this is actually it's not actually the question for me. It's actually the question for the persons that just defined basically the architecture of this mission.
All right, the next question is from Majri Zied. He's from Astronomical Club Astromed in Tunisia. He said, is there actually a way to protect Earth from big asteroids? I mean, redirect them far from Earth or expose them, or it's still behind actual technology?
All right, so this has been already mentioned in my presentation, and this is the main of this mission. So as I said, there is different techniques to do this. There is the normal simple techniques we estimate theoretically that will happen. As I said, there is a slow gravity tractor that is pulling by the asteroid. There is a mid-range kinetic impactor, like to slam the asteroid and to change the orbit, that we will do it. There is a third technique, is like the laser ablation, vaporize the rock of the asteroid to create jets, and then as a consequence to push the asteroid. And there is a major or the worst case scenarios used, which is a nuclear option, that is basically to use a nuclear, nuclear energy to vaporize rock to destroy it, basically. Well, I think you saw this in certain films. So this is the major let's say tool, the worst case method that we use in case we don't have enough time to pull it, or in case it's huge, we cannot really manage it, or we can just destroy it from inside. It's actually the most effective way to have less impact on Earth.
All right.
I just have a question.
Yeah, go ahead, Sidqi, go ahead.
Yeah, so I just wondering if would it be possible to land on asteroids, for example, send a robot or something like this?
Yes, actually, there has been missions that have been planned for this, to send robots, not robots, or maybe small radars, small instruments on it. Of course, robots will be also effectively it's the same principle. It's just using any kind of technology that will land on the asteroid and take more measurements. So yes, it's possible. And there are a lot of missions that started, I think, on that side, and that will be also in the next years using this, because we need to characterize, we need to find out the properties of the different asteroids. There are several ones. This is actually, I believe I know just 1% of them. There is a lot of kinds of asteroid in compositions and in sizes and more. So the only way to do this is to send, as you just mentioned, the robots or the different technologies, just to check the measurements and to check the properties.
Okay, thank you.
And then, Rania, the next question is from Ababil from Mexico. He said, how close does an asteroid have to be to hit the Earth?
Okay, this, you cannot really define this, because if it is fast enough, you have to do it, how to say, we don't measure it that way. We don't see if it's close, like 200 meters, we should just find a way to make it. This is dependent on several parameters, as I said. I said the major ones that are the size of the asteroid, and I said again, I forgot. Okay, the size and the speed of the asteroid, and actually this is defining basically which tool we will use. We cannot really find out just for the distance that is coming by. there is a lot of other, I'm not really able to define it right now, but actually there is several number of parameters we try to check about the asteroid when we try to track it, if it cause any kind of impact, or if it will be like, it will even approach the moon, or it will approach the Earth even from far, or the energies that will engage and more. So, and this, based on that, we can just define what kind of techniques we can do, or we just try to change the orbit, and that's all.
عايشك رانيا. السؤال الثاني من عند مسيو نوفل بن معاوية اللي هو أن أستخدم في السيتي دي سيونس دي تونس. نحب نشكره برشا خاطر قاعد يتابع فينا من أول معناتها الكونفيرنس. يقول سي نوفل est-ce qu'on peut estimer le nombre d'années avant un tel impact d'un astéroïde avec la Terre?
Le nombre d'années, oui, on peut l'estimer. On peut l'estimer, bien sûr, si on est capable de déterminer exactement la vitesse de l'astéroïde, si on est capable de comprendre comment l'astéroïde il agit, comment il est son orbite, comment il bouge. Oui, on est capable de déterminer en nombre d'années, en nombre de jours et en nombre de mois quand est-ce qu'il va s'approcher et exactement où il va s'approcher. Heureusement, ces dernières années, on était capable de faire ça. Donc, on est réellement savoir la distance qui sera entre l'astéroïde et nous, ou s'il y a réellement un impact, et ça sera exactement à quelle heure et à quel instant il va passer. Donc là, oui, on peut le caractériser. Il y a des télescopes qui ont cette capacité de déterminer. En fait, celui qu'on utilise, ou l'observatoire qu'on utilise, c'est celui de la NASA. C'est ce qu'on appelle le NASA Infrared Telescope Facility. Ils ont un télescope très optimisé en utilisant l'infrared images and other measurements. They will be able really to track the exact moment of this. So yes, we can do this.
يعيشك رانيا. السؤال السويفون يقول what does scientists learn from mission to asteroid?
What we learn is the data coming out, okay, for this mission, for example, since I'm involved in it. So what we will try to learn is first, as I said again and again, the characterization of the asteroid, the mass. So once we know the mass of the asteroid, the composition of it, how hard it is, for example, just to make it simple for you. So that to know if you are really able to use any possible technology, the laser, the nuclear weapon, the nuclear energy, or any other energy possible. So once we know these properties, we are able to determine any kind of technology we have or we need to develop to destroy. So this is basically the things that the scientists need to take from this kind of missions. Like if we can find out a way to change, to destroy it, to avoid any threat. And also, of course, as I said, the importance of this asteroid as a resource, because it has a very valuable, it's very valuable for scientific needs, and also for it's very expensive, so we can need it. It can be a source of energy, and we can use it in several other options as well.
All right. The next question is, does there a law in space defense?
A law? Of course there is. There is actually several treaties that have been already conducted by UN COPUOS. There is specific treaties on near-Earth orbit objects, specific ones on the use of nuclear weapons. So this is very sensitive topic. So if we will use the nuclear option, we should all agree on it, and we should all assume the consequences of it. And of course, the impact of any kind of asteroid in the world, actually it should be an international collaboration. It's a must to have everyone involved in case of threat, because of course, you know, if it will be in any point of the world, all the other regions will be impacted as well. So yes, there is specific treaties that of course need to be more developed, but yes, there is several treaties by the UN COPUOS, Committee of Peaceful Uses of Outer Space, that is basically the main assembly or the main committee that is taking care of all of the international treaties of space, of the outer space.
Okay. Donc نرجع مرة أخرى Monsieur Nofel يقول لك même avant 10 ans pour estimer le nombre d'années avant un tel impact d'un astéroïde?
Même avant 10 ans, je ne sais pas et je ne pense pas. علاش? En fait, l'idée, c'est que si tu sais qu'il y a un astéroïde qui a 10 ans, qui a besoin de 10 ans pour venir, c'est que tu sais que cet astéroïde, il doit venir à la Terre avec une certaine vitesse, avec un certain élan, et tu es réellement capable de to track it several years ago. So far, I don't think that there is one. Maybe I don't know everything, but l'idée, c'est que quand tu as 10 ans, moins de 10 ans, bien évidemment, si tu le suis depuis un certain nombre d'années, donc normalement, tu dois savoir ça. Mais avant 10 ans, je ne pense pas. Plus que 10 ans, ça sera un peu... c'est encore loin, on n'est pas réellement capable de voir ça aussi exactement. Et je ne sais pas s'il y a réellement un qui va venir, je ne pense pas de toute façon. Donc, les estimations, ce genre d'estimation, ça se fait, ça dépend depuis quand on le suit et comment, on connaît réellement et on comprend exactement comment il interagit. Mais si on sait réellement que plus que 10 ans, donc ça doit être assez loin et on n'est pas réellement capable de tout caractériser par détail. Comme vous savez, on n'a pas réellement tous les instruments qu'il faut pour pouvoir traquer ça.
Ok, Mariam El-Hirsch, مرحبا بك معنا. Si tu as une question لرانيا ولا commentaire, donc مرحبا بك. Donc sinon, je passe aux dernières questions, Rania. Dernière question, what is the future challenge and project in planetary defense?
The future project, the one major project is ADA. It is the DART and HERA mission. So the DART, as I said, it will be in 2022. This is a major one. There is HERA that will track it after a couple of years. So this is the main project we are working in. So we will try to use one of these techniques I have mentioned. We will try to slam it and to wait and to see the impact and what kind of characteristics we have so far. Myself, I'm actually in the engineering part of the engineering international network. I'm not part of the scientific network, so I'm not in the dimension of characterizing like in detail. But as far as I know, so we still miss a lot of details on this point. We just need such missions to understand the way we can defend ourselves. So this is the one that is planned so far, but I'm sure that there is actually more coming by. And I know that ESA is planning to make another one to check another technique of asteroid deflection. Again, so this is actually a collaboration work. It's not only the role of just engineers to answer all these questions. It's actually the work of scientists, geologists, of everyone to bring inputs on the understanding basically how these objects behave, how these objects will be, when we should interact, when we should just send our tools, our spacecrafts to defend ourselves, if we are really able to track it or not, the number of years we need to track an asteroid and to understand the dynamism of an asteroid and now the way how it's orbiting. So far, but I believe that the technologies are used now for telescopes are really well advanced. So we use the telescopes for stars tracking, but there is actually specific ones coming by.
Thank you so much, Rania, again. It was really a very cool and amazing talk about planetary defense near Earth orbit and also about the future project for planetary defense. Once again, I would like to thank Rania Toukebri. She is a space engineering working in the spacecraft architecture like Space Mission, JUICE, Biomass, Plateau, and here, and also the regional coordinator for Africa and Space Generation Inventory. Thank you, Rania, again. And it was really a nice talk. I would like also to thank all of our followers in YouTube channel and also Facebook page, which they were following us in this talk. Thank you, Rania, again. And I will hope to see you the next time in the next talk.
Thank you, Maisa.
Thank you. Bye-bye, everyone.
Bye.